In this video, let's study another property based on the concept of properties of determinants. We have already seen 5 properties on the same. This video is dedicated to the property number 6. Let's see what the property is and we'll be seeing the theoretical analysis. The property says the value of determinant remains same or remains unchanged if we apply some operation like this or some operation like this. This you can see is having R, that means rows. This is related to C, that means columns. So before understanding what theoretically it means, let's see an analysis and we'll understand it accordingly. I have a determinant and it is A1, A2, A3, B1, B2, B3, C1, C2, C3 that I am taking into consideration, and let me name this as del. Now if del is this determinant and I apply any operation on the row or column in this manner, not changing the definition, nothing to change, the value should remain same. That is what we need to see. Okay, if A1, A2, A3, B1, B2, B3, C1, C2, C3 have some value called as del, and I now change it to del 1, and my del 1 is what? It has some operation applied, and let me take for simple considerations the operation in the case of a row. So the first row will be changed. If I am applying operation on first row, it will become A1 plus K say P1, and here also it should become A2 plus K P2 and something like this. But we cannot take P. Why? Because if you see the definition, it is Ri, means if you have R1, then it should be R1, then R1 plus K R say 2 or 3. So if I take 3, then it should be R3, and is P there in R? No, it is ABC. So you cannot take P. This is one mistake that usually people commit. So what we are going to do is, we are going to take a scalar, that is K or any other value, and now we are going to apply this operation and we will see whether the answer remains same or not, right? So it is K P1, no, not P1 in this case, we are applying on R3, so R3 is basically your C, so it has to be C1, then A2 plus K C2. Now I hope you are observing and following, it is A3 plus K C3, right? Next, no changes in other rows, no changes in other rows. B1, B2, B3, and here it is C1, C2, C3, right? Now, if this is the case, I know from the previous property, that is property number 5, if sum is there of 2 elements, 2 elements, 2 elements, you can split the determinant always. So let's split it. It becomes A1, B1, C1, A2, B2, C2, A3, B3, C3, right? That is the case of the first determinant. And what about the second determinant that we need to see? My second determinant will be having KC1, KC2, KC3. So it is KC1, KC2, KC3. Changes not in any other thing. So don't change B1, B2, B3 and C1, C2, C3, right? So it is B1, B2, B3, C1, C2, C3. What I have done is, let me repeat again, I am actually verifying this property number 6 and applying the use of it. So I have a determinant which is known as del, and del 1 is another wherein some modifications are done in the row 1, R1. Now splitting into 2 determinants is what we did. Now you see this determinant is what? A1, A2, A3, B1, B2, B3, C1, C2, C3. Something familiar? Something familiar to what? To del. So this is del. Del 1 is what we are evaluating. This has come out to be equal to del plus something. What is that plus something? Let's see. Now if you observe the second determinant, this is row 3, C1, C2, C3. This is row 1, KC1, KC2, KC3. Take out K common. It becomes C1, C2, C3 only. 2 rows identical, 2 rows proportional. The answer to this determinant is 0. Now what is anything plus 0? It is the same thing. So it is del only. Here it is del 1 only. So you follow that del 1 equal to del in this case. That means what? That means any determinant is given and you apply any operation such as the ones described above in the case of rows and columns, the value doesn't change, the value remains the same. That is what is the motto of this property.